to this class. Yes, in this class, I'm going to be engaging you on indices and logarithm. So this is the introduction. As you can see the analysis on the board, this is 2 cubed equals to 8. So I'm going to analyze the components of this expression. Now, whenever you see a number carrying another number, that number that is carrying the other number, is the base. Why what is being carried by the base is the index, and that is why the word indices come from. Indices is talking about being carried by somebody. So the person that is carrying the indices is the base, while the indices is always standing on the base. So here 2 is the base, while 3 is the index. Now when you evaluate this the base and its index, we are going to get a result. Now when we now want to discuss on indices, we must always talk about logarithm, because to me indices and logarithm are like partners. They are opposites. So indices and logarithm must come simultaneously. So you cannot learn indices without learning logarithm, and you cannot learn logarithm without knowing indices. Very simple. So now based on this, you must know that when you want to transform this whole expression as you have seen it here is an indices. So there's a way you can transform an indices into what? Logarithm. And that direction is this direction. So this direction is the logarithmic direction. Logarithmic direction. How? That means if you can make this base to carry the result, then that direction is for the logarithm. For instance, log 2 raised to the power of 8 will give you 3. That means logarithm is a reverse equation, or a reverse principle to get our indices. So if I want to get this index as my result now, as my new result, what I just need to do is to use the base of that index to carry the result. So if 2 can carry 8 and we attach log, then I will get the index. So this index on a power will produce the result. But if you use the base of the index to carry its result attached with logarithm, you will get the index. So that means logarithm and indices has a way of connecting to each other. That means if I can attach log to 2 raised to the power of the result, 2 raised to the power of 8, I will get 3. How? You know, you can express, let's prove this. Let's prove if this is correct. You can express log 2 raised to the power of 8 as what? Log 2 raised to the power of 2 cubed. Because 2 cubed means 8, alright? 2 times 2 times 2 times 2 is 8. Now, according to logarithm, when something has a power like this 3 can come forward. This will be what? 3 log 2 base 2. And there's one rule. After this video, I'm going to give you another video on laws of logarithm. Now, it says log of the same base and power equals to 1. So if this whole thing I circled is 1, that will be 3 times 1, 3. What do we get? 3, the index. That means if you want to make any expression that is in indices form to become a logarithmic equation, just let the base carry the result and attach log. So for instance, if you say 2 raised to the power of 4 equals to 16, to change this indices to log is going to be what? Log, let this base carry this result, 2 raised to the power of 16. Then if you evaluate this, you must get the indices, which is 4. So that is how indices and logarithm connect with each other. I hope I've been able to introduce you to indices and logarithm. In the next video, I'm going to be discussing about the laws of indices and the laws of logarithm. So we are going to place this side by side to each other, then you know the difference between the two. Then after that, we are going to go into calculation question. I love you so much, and God bless you.